We will start with the Alive supervision in details. Now we will talk about the parameters that you need to configure for the Alive supervision option. The first parameter you need to know is the supervised entity periodicity. What is the supervised entity periodicity? This is the entity or runnable that you want to monitor its periodic behavior. For example, 5 milliseconds runnable in your software. And you want to monitor its behavior, whether it execute every 5 milliseconds or not, with configured tolerance that we will take about later. The second parameter is the Watchdog main function periodicity. This is the periodicity of the Watchdog main function that you configured in the basic software. It can be 10, 20, or 100 milliseconds. It is your decision to take in the architectural design. The third parameter is the reference cycle. This parameter defines when you want to evaluate the runnable that you want to monitor in the software. Let's say we have the 5 milliseconds runnable, and we will evaluate the 5 milliseconds every 100 milliseconds. So, every 100 milliseconds, the Watchdog main function will execute evaluate code to figure out whether the 5 millisecond runnable execute in time or not. We will know later how Watchdog main function do this evaluation. But let's continue in our parameters. The fourth parameter is the Alive indication. The Alive indication parameter is simply a parameter which increased by 1. Each time, runnable calls Watchdog Manager checkpoint reached. This is important. You must put this checkpoint reached function at the end of the entity that you want to supervise. Every time the 5 millisecond or 10 millisecond entity that you supervise come, it will call this function, the checkpoint reached. You can think it as a counter. Every time the checkpoint reached, called the counter incremented by 1. Then we have the expected alive indications. This is the next parameter that we will talk about, which is the expected alive indication in the period of reference cycle. We can say in the 100 milliseconds that we will do our evaluation to evaluate whether the entity executed correctly or not by comparing the alive indications with the expected alive indications. We expect that the runnable increases the counter, which is a live indication to a certain number. For example, as we said, we have 10 millisecond runnable, and we do the reference cycle at 100 milliseconds. So what will be the expected alive indication in a perfect world? It will be 10, because 10 milliseconds runnable will run 10 times in the 100 milliseconds. So it will set the counter to 10. At this reference cycle, it will check whether 10 cycles have been or not. If 10 counter increased, so this entity or runnable is behaving correctly. But this is in a perfect world. In automotive, we have a maximum and minimum margin. The maximum and minimum margin protect us from false resetting, because the 10 milliseconds will not execute 10 times in 100 milliseconds. As we have here, jitter and latency and other dynamic behaviors will occur. The entity can execute 9 times or can execute 11 times. This is due to the variation or the jitter in the Watchdog main function, or the entity that we are supervising. We can observe a 9, 10, or 11, and sometimes we can see 8 or 12 executions. This is according to the priority of the entity and whether it is a lower priority or high priority and how loaded our system is. In this case, we can say that after 100 milliseconds, you can check whether you have 8 or 9 or 10 or 11 or 12 alive indications. So the system is okay. But if you have 7 executions, for example, in 100 milliseconds, and your system will be affected by that. So here come the min and max margin. This is why there is a maximum and minimum margin. Next, the evaluation equation in details. The actual indication called by the supervised entity less than or equal to the expected alive indication minus the minimum margin, and greater than the expected alive indication plus the maximum margin. As we said, if we have a 10 millisecond and every 100 milliseconds, we review or evaluate the entity, whether it's functional correctly or not. We have 10 alive indications because this runs every 10 milliseconds. So after 100 milliseconds, it will come 10 times. But if the minimum margin is 1 and the maximum margin is 1, so we allowing from value 9 to value 11 executions. So 9, 10, 11 are all correct values and will lead to a correct evaluation for the supervision entity. Now, another parameter that we need to talk about, which is the failure tolerance. This parameter is related to the supervision local state machine. This will be more understandable in the next slides when we describe the supervision local and the global state machine. This is the failure tolerance, which says how many times a live supervision has to fail before we set the local state machine to expired state. Don't worry, expired state will be described in the next slides in details. As we said, the local state machine is for every entity you define in the software and set supervision to it. For example, the runnable 10 milliseconds have a local state machine. If the alive supervision after 100 milliseconds failed, you could set the failure tolerance to 2. For the first time, it will not lead to a reset. It will give another chance, another 100 milliseconds, to evaluate again the runnable and say whether it is working correct or not. But after this failure, tolerance is consumed. This will lead to action from Watchdog Manager module.